Today we're going through 7G. So probably what I'll do, I'll go through this. This is very standalone, so if you haven't done 7F yet, no worries, you'll be able to pick this up fine. And for those that haven't done 7F, I may try and catch up with you together, or you can just watch the video. So I'll let you make a decision. So we're applying these formulas here. There are some ones for tan, but I haven't got examples for tan. I'm just going to go through these three examples here, where if we start with something like this, we can expand it out, okay? Or if we start with something expanded, we can simplify it. They're sort of like expansion and factorisation is an easy way to think about it. So over here, our first angle is always going to be A, and our second angle is always going to be B. We've got theta plus pi. And so when I'm looking over at my list of rules here, for you, I'll put them at the top of the page. I'm going, which one does this correspond with? Okay, and this corresponds with our first one. Here we have cos A plus B. So in this circumstance, theta is A and B is pi. So we're just going to fill it in. We're going to expand it to be that. That's our very first step. So that's going to be cos A, here it is, cos A, cos B. So it's going to be cos theta, cos pi. All right, cos theta, cos pi. Take sine theta, sine pi. Okay, so that's the link between the formulas there, and then we're just going to simplify it accordingly. So when we've got pi, and I encourage you, rather than just going straight to your unit circle, think about these things. So at pi, that's here on the unit circle, that has an x value of -1 and a y value of 0, which means at this point, cos is -1 and sine is 0. So here we've got cos of pi, that's going to become -1. So we've got cos theta times -1, and then we have to take sine theta times sine of pi is 0. Okay, so then to write this in simplest form, it is minus cos of theta, -1 log of cos theta. Okay. Next one. We've got sine of theta take pi on 4. So again, we're going to look at our list. We need to expand it and simplify it. We're saying, which one does it correspond with? So it's not cos, it is one of the sine ones, and we have the first angle take the second angle. So this is going to be the expansion we're performing. Again, this corresponds with A, and this corresponds with B. So we're going to have sine of theta, cos of pi on 4. And then we've got take cos of theta, sine of pi on 4. And then we can simplify. So pi on 4, that's 45 degrees. That means both the y value and the x value are the same. Sine and cos are the same. It means they have a length of root 2 on 2. And as well, I'll just emphasize that point here, good opportunity to emphasize it. Root 2 on 2 is also equal to 1 on root 2. There are multiple ways that can be expressed. Okay, so let's substitute that in. Cos of pi on 4 is root 2 on 2. So it's sine theta times root 2 on 2. Take cos theta times root 2 on 2. Sine of pi on 4 is also root 2 on 2. All right, and there's lots of ways we could write this. It's root 2 on 2 times sine theta take cos theta is probably the simplest way to write it. Okay, very good. Let's move over to question 2 here. And so now we're starting with something expanded and we want to go back the other way. So given this is A and this is B, this is A, this is B, that's always the case. How can we go back the other way? Which one does it resemble? So it's cos A, cos B, plus sine A, sine B. It's this one, isn't it? It's the second one here, which means when we go back to its simpler form, it's going to be cos of A take B. So it's going to be cos of theta take away 2 theta. which is cos of minus theta. And that would get you full marks there, okay? But I'll just make one connection. Cos of minus theta is actually also equal to cos of theta. And I'll explain why, right? If you've got your unit circle here, okay, and let's say I go 30 degrees, okay, that would be there, and I go 30 degrees, I go negative 30 degrees, that would be there. They are going to have the same x value. It doesn't matter on the size of that angle, that cos theta is always going to equal cos of negative theta. That they're going to mirror each other on opposite sides of the Cartesian plane, even if you were to keep going around. So that cos of minus theta always equals cos theta. And I believe this is an identity we've mentioned before. Nonetheless, you get full marks there. Okay, so 7G, let's give it a go. Just question 2 and 4.